Hello Stonites, welcome to the third video of relations and functions. So in this video we shall discuss about the functions, and that is the most critical part of your chapter. And remember that if you understand the functions properly, then the whole concept of your grade 11 mathematics as well as grade 12 mathematics will be very easy for you. So let us see what is a function. So before that, we have discussed about what are Cartesian product and what is relation. So here I have two relations, two examples say. So the first relation I have defined is that it has the elements ordered pairs A1, B3, C2, B2. Let us draw that. So if I draw the arrow diagram for the relation 1, suppose this is the relation 1, and here say this is the set A and this is the set B. Now what are the domain here? What are the elements of the domain? It's A, B and C. And what about the range? It is 1, 3, 2. So here if we associate the elements according to our ordered pair, so it will be A will be associated to 1, B is to 3, C is to 2 and B is to 2. Fine? Okay. Now let us take the second case. Here we have taken another relation, that is R2, and let us name these two sets as A and B. Now what are the elements here? It is A, B, C, and here the elements are 1, 3 and 2. Fine. Now A is associated to 1, B is to 3, C is to 3 and B is to 2. Okay. So we have two relations here. Now you know the concept of relation, that to define a relation actually it is the subset of this R1 is the subset of the ordered the Cartesian product of A and B. Fine. Now what about the functions, whether these two relations are functions or not? So basically a function is a special type of relation satisfying certain properties. So what are the properties? Here you can see that this element A is associated to 1, B is associated to 2 elements here. Similarly here C is associated to 2, and in this case all the elements are associated to some of the elements here, but in both the cases we can see that this B has been associated to 2 elements. That means B has 2 images. Similarly here B has 2 images. So both of them are not functions. They are relations but not functions. So when they can be a function? If I remove this pair, that is, and also if I remove this pair, that is, now B is associated to only 3, and here B is associated to 2 and C is associated to 3. So it's fine. That means I have considered all the elements in the domain and they are associated to a unique element in the codomain. Then we can say that these two relations are functions if this property is satisfied. So in other way, what we can say that every element of the domain will have a unique image. Fine? Okay. So if I write another element here D, will it be a function? No. The another condition for a function is that the set A is the domain, which was different in case of relation. In relation we have seen that the set A and the domain are different. They might be different sometimes, but here the A and the domain will always be same. That means there cannot lie any element extra which is not associated to any element in the codomain. Fine? So this thing cannot happen. Also, a single element in the domain should not be connected or associated to 2 elements in the codomain. So these are the two main properties. And one more thing is that if any element is remaining behind in the codomain, then it's fine, even though we shall say the function. So the only thing is that all the elements of the domain must be connected to some. Okay. So mathematically how do we define? So for our sake, let us say that earlier we have, in case of relation we have taken R1 and R2. So now since we are discussing about functions, so we shall denote the thing by F. So whatever relation we get such type, we shall denote it by F. And F, if we can define a relation from A to B, then we shall say that F is a function from A to B. Fine? So what we get? F is a special type of relation. Okay. Now since F is a relation, so what are the elements of F? It will be the ordered pair, that is a comma b will belong to f. Now if a comma b belongs to f, then what? Then we can write f of a is equal to b. This is a property of the functions, okay? And where does this a and b belong? Thus a will belong to the capital A and small b will belong to the capital B. So this is all about relations. Now let us see what are domain, codomain and range, image and pre-image. So let us take the case of this function here. So what is the domain here? Domain is A. So in case of functions, the domain and the first set will always be equal. What is the codomain here? Codomain is 1, 3, 2. That is the set D. You can write, or 1, 3, 2. Same thing. What is the range here? Here the range is 1 and 3. Okay. So because this element is not associated to any of the elements from the set, from the first set. What is the image? Here we can see that 1 is the image of A, 3 is the image of B, and 3 is the image of C. Same as the relations. And A is the pre-image of 1. This A will be called the pre-image of 1. B will be called the pre-image of 3, and C will be called the pre-image of 3. Fine. So that is all about your function, and now we shall see a few more functions with their graphs. So now we have a few functions, and these are very important for your grade 11 as well as grade 12, and please have clear concept of these functions that I am going to explain you now. So this will be helpful for your entrance exams as well, and even if you are pursuing higher mathematics, then this will be very helpful for you. So let us see the functions, what they are. The first one we have identity function. So what is an identity function? Actually it is a function from the set of real numbers to the set of real numbers. So okay, if a function is defined from the set of real numbers to the set of real numbers, then what is it called? It is called a real valued function. And also if the domain is also real number or the subset of the real number, then it is called a real function. Okay, so if a function f is defined from R to R by f of x is equal to x, okay, for all x belongs to the set of real numbers, that means belongs to the domain. So such type of functions are called what? Identity functions. So how will it look like if I draw the graph of this identity function? Here I shall have 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay, so this is our origin. So here we can see that for whatever x we put in the domain or we take in the domain, we shall get the same x in the codomain. Okay, that is the range, sorry. So we shall get the same x in the range. So if I take, since our x belongs to the real number, so I can take 1, since 1 belongs to R. So if 1 belongs to R, therefore f of 1 will be 1. So, and what is f of 1? It is actually y, isn't it? So if I take x is equal to 1, I shall get y is equal to 1. So our point will be this. So for 2 belongs to 1, we shall have f of 2 is equal to 2. So f of 2 is equal to 2, we shall have the point here. F of 0 is equal to 0, we shall have it here. F of minus 1 will be minus 1. The same thing, whatever we are taking, we shall get the same thing. For 2 we shall get 2, minus 2 we shall get minus 2. For minus 3 we shall get here minus 3. Sorry, minus 3. So that means we can say, we can see a straight line. A straight line has been formed that is passing through the origin. So this is the graph of the function, that is the identity function. Okay, and that is all about identity function, and the graphs look like this. So now let us see the constant function. What is the constant function? So similarly, a constant function is also a function that is defined from the set of real numbers to the set of real numbers. What is the change here? It is defined by f of x is equal to c. for all x belongs to R and C is a constant. It's a constant value. Okay, so how will the graph look like? If I again draw the coordinate system, let it be 1 2 3 1 2 3 0. Okay, so if I take the function here, f of x is equal to c, and what is f of x? Actually it is y, isn't it? So for whatever value we take for x, we shall get y constant. So for our assumption, let us take c be 4. Let us take c is equal to 4 for our convenience. Then whatever value of x we take from the domain, what is our domain? It's the set of real numbers. So whatever x we take here, we shall have f of x is equal to 4. So let us draw the graph here. If we take x is equal to 1, then what will be our f of x? It will be 4 here. If we take x is equal to 2, it will be 4 again. For x is equal to 3, f of x will be 4. X is equal to -1, it will be 4. X is equal to 0, it will be 4. So for whatever value of x we take, we are getting 4, isn't it? So we are getting a straight line that is parallel to the x-axis. Fine. So if our value of this constant changes, suppose it is 3, then what will happen? We shall get a line here. If it is 2, we shall get it here. If it is 0, then the x-axis and the straight line will coincide. That means they will be same. So that is all about the constant function. Now let us see what is polynomial functions. So in your lower classes, that is in grade 9 and 10, you have come across what is a polynomial. You have come across polynomial, isn't it? What is that? It was written by f of x is equal to something x square plus twice x plus 3 and all those things. So if I write it generally, what will it be? It will be a0 plus a1x plus a2x square plus a3x cube and so on, isn't it? A polynomial will look like this. Okay, now these kind of functions are called polynomial functions. So specifically this general polynomial does not have any graph, so if we change the constant accordingly, our graph will change. So for our convenience and also for this function, the domain is R and the codomain is also the set of real numbers. Okay, so for example, let us take a function f of x is equal to x squared. So is it a polynomial? Yes, it is the polynomial where a2 is 1, value of a2 is 1 and all other values, all other constants are 0. So it is this polynomial actually. F of x is equal to x squared. Now if I want to draw the diagram for this specific case, here for f of -1, what shall we get? It will be 1, -1 square will be 1. F of 0 we shall get 0, f of 1 we shall get 1, f of half we shall get 1 by 4, f of minus half we shall get 1 by 4 and so on, isn't it? So if you draw the graph, it will be this type. Okay, so here if it is 1, so this will be the point 1 0. Here if it is half, so it will be 1 by 4 here, so this point for half minus half, this will 1 by 4 here. So we are getting actually a parabola. You will learn about this in your conic sections, in the chapter conic sections. So this is a special type of function for which we are getting this graph. So similarly, as our polynomial changes, accordingly our graph will also change. Okay, now let us see what is rational function. So rational function, here at first let us see the function. What is a rational number? Rational number is a number that is of the form p by q, isn't it? And the condition is that q will not be equal to 0. Okay, otherwise it will be undefined. So what about rational function here? Simply if I put p of x and q of x, that means x is the variable. Now these two are functions. So such type of functions are called rational functions. So what will be the condition here now? That is q of x will not be equal to 0. This cannot be 0, otherwise the function will be undefined. So what about the domain? Will there be any change in the domain? So here you can see earlier our domain was, we have taken the function from R to R, but now if this q of x is 0, then our function will be undefined, isn't it? That means we can take any value of x here except 0. So our domain now will be R minus 0, that is f will be a function from R minus 0 to R. So that is the basic thing about a rational function. So for example, I can take f of x is equal to 1 by x. So clearly x cannot be equal to 0, isn't it? So and if you solve it, if you put any value, you will get any real numbers only. Okay. So that is about rational functions, and actually this is not that important, this function. Next, let us see what is modulus function. A very important function in throughout your mathematics career, it will be very important. So actually modulus function is a function from R to R, okay, and it is given by f of x is equal to mod x. This is called modulus of x, or in short we can say mod of x. So what does this mod of x represent? Mod of x is equal to positive x when x is greater than equal to 0, and it is equal to negative x when x is less than 0. Fine. So that is the definition of mod of x. Now if you are confused here, let us see the diagram. How will it look like? If this is our x-axis and y-axis, and this is the origin, 1 2 3 1 2 3 minus 1 minus 2 minus 3, okay. So here if I take x, okay, where does this x belong? X belongs to the domain, that is the real numbers. Now if I take x is equal to 1, then what will be mod x? If our x is 1, this x is 1, so our mod x will also be 1, so it will lie here. If our x is 2, so since 2 is greater than equal to 0, so we shall take our range, that will also be 2, so we shall get 2 here. Now if we take this x is equal to minus 2, then what? Minus 2 is less than x, so in that case we shall take this function, and what does this function represent? It is minus of minus 2, so this will give us 2 again. That means if we take x is equal to minus 2 here, so our output will be 2 here, okay. So for mod of minus 1, we shall have minus of minus 1 is equal to 1, so it will be here. That means our function will look like this, or just, yeah, it will look like this, okay. So that means for whatever value of x we take here, whether it may be positive, negative, whatever it may be, but our output will always be positive quantity, okay. So that is all about the modulus function. Now let us see what is signum function. It is another important function. Actually signum function is a function that is defined from the set of real numbers to the set of real numbers, okay, and it is defined by f of x is equal to minus 1 when x is less than 0, equal to 0 when x is equal to 0, and is equal to 1 when x is greater than 0 for all x belongs to the domain. Fine. Now what does this say? Whenever it is almost similar to the modulus function, but the only difference is that earlier it was x and now we are considering minus 1, and here earlier it was minus x and we are now taking it 1, okay. So if I draw the function here, see, it is very interesting. For whatever value of x we take, and x must be less than 0, okay. So let us take x is equal to minus 1, it is less than 0. So when x is minus 1, that means this portion in here it is minus 1 here. So what will be our y? Y will be minus 1, okay. This is minus 1 and this is plus 1, this point. So if x is minus 3, here x is less than 0, so we shall have f of x is equal to minus 3, this point, sorry, minus 1. So for whatever negative value we take, our function will give us -1 only. That means we shall get a straight line here for whatever value, negative values. And for whatever positive value we take here, if we take x is equal to 1, what we are getting? X, since here 1 is greater than 0, so we shall take f of x is equal to 1. So for this point we shall have this here. If we take x is equal to 5, 5 is greater than 0. So for 5 greater than 0, we shall have f of x is equal to 1 here again. So 1, 2, 3, 4, 5, we shall have this point. So basically for whatever positive value we take, we shall get a straight line, that is we shall get a line fx is equal to 1. Okay. Now what about these points? These 2 points. Remember that we are in these 2 cases, into straight lines, we are not considering the point zeros here. In both the cases it is less than and greater than. So what about when x is equal to 0? When x is equal to 0, we shall get f of x is equal to 0. Okay. So this is all about the signum function, and it's a very important function. Now let us see the greatest integer function, another important one. Okay, one more thing. Here we have come across f is a function from R to R in case of the signum function, isn't it? That is f of x is equal to -1, 0, 1. So here the domain was R and the codomain was R. What about the range? Here the range of f is -1, 0 and 1. Fine. Okay. Now let us see this greatest integer function. The greatest integer function is also a function that is defined from R to R. Okay. Now what is the speciality of that? It is defined by f of x is equal to the greatest integer function x. This x is written inside the third bracket. So what is the role of this particular function? Actually, it determines all the values or all the integers that is less than or equal to x. Okay. So for specifically, if we take x is equal to 0.6, then greatest integer function x, or this will give us 0.6, will give us 0. What is the nearest value, the greatest or the least integer to it? It is 0 here. Now if we take x is equal to 1.9, then the greatest integer function 1.9 will give us 1, the least integer that it contains. For x is equal to 3.1, 3.1 is 3. So always we are considering the least integer. So that is all about the greatest integer function. Next we have algebra functions. So here, if f is a function from say x to r, it is actually real valued functions, and g is a function from y to or x to r, where x is a subset of r. Okay. Then we shall have the algebra functions like f plus g of x is equal to f of x plus g of x. Number 2, f minus g of x is equal to f of x minus g of x. 3, fg of x is equal to f of x into g of x. And 4, alpha into f of alpha x is equal to alpha into f of x, where alpha is any scalar or any constant, you can say. And number 5, f of x, fg of x is equal to f of x divided by g of x, where g of x is not equal to 0. So that is all about the algebra functions, and in the next video we shall come up with exercise 2.3. So till then, stay home and stay safe. Thank you.